So today we're going to continue on with chapter 2. We're going to cover section 3, and we're going to use postulates and diagrams. So this section has a bunch of different postulates that you should memorize. The next screen has several. We got 4 of them here. Now, keep in mind that you do not need to memorize that postulate 2.1 says this. Through any 2 points, there is exactly 1 line. You just need to know that through any 2 points, there is exactly 1 line. And we already talked about this when we learned about points and lines. However, now it's officially being presented as a postulate. The next postulate here is a line contains at least 2 points. So it can have no less than 2. So it needs a minimum of 2. Notice the words at least. So again, most of these we've already talked about. Now it's just being officially taught to you as a postulate. And again, do not memorize postulate 2.2 states that a line contains at least 2 points. I will not ask you on a test or a quiz to tell me what does postulate 2.2 state. Then the next one is postulate 2.3, and that one states if 2 lines intersect, then their intersection is exactly 1 point. And we already talked about this, so their intersection here is this point. And then the next one, through any 3 non-collinear points, there is exactly 1 plane. So notice here the word non-collinear, they can't be on the same line. So if I draw a plane and in it draw 3 points, they can't be on the same plane. Now, postulates, these are things that are determined from a definition or a rule. That's where they come from. So they come from either a definition or a rule. We've got 3 more on the next slide. Next one, again, don't memorize the numbers. Next one states a plane contains at least 3 non-collinear points. It can be more than 3 points, but you need a minimum of 3 non-collinear points to name a plane. Then the next one, if 2 points are in a plane, then the line that contains them is in that plane. So if I draw a plane here, and then if I add 2 points, then the line that goes through those 2 points is also going to be in that plane. And then the last one says, if 2 planes intersect, then their intersection is a line. We already talked about this. Remember, planes go forever, so the planes aren't going to intersect in a line segment. They're going to intersect in a line. So let me see if I can draw 2 planes. Draw one on top. I'm going into the words. Well, let's see if we can make it look like it's behind. I don't know. So their intersection would be a line. It could be like this. You can sort of think of like 2 pieces of paper. Let's see if I split this. So like if I have, let me turn on my cam. So like if I have 2 pieces of paper, and if I were to intersect these 2 planes, these 2 pieces of paper, their intersection where they're going through would be a line. Also think about your house. Like if you look up at the ceiling and the walls, up at the top where the wall and the ceiling meet, it meets at a line, okay? Granted, your ceiling and wall don't go forever, but you just have to imagine that it keeps on going. Let's try the next one. Perpendicular figures. Okay, notice this is a biconditional. Notice the words in here, if and only if. So a line is perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. So notice here is the line going through. And notice these little red marks indicating that it's perpendicular. And any line that's going to go through that is also going to be perpendicular. So let's try and see if we can figure out which postulate is illustrated by the diagram on the next slide. So from this illustrated diagram, they want us to state the postulate. Now, we're not going to say it's postulate 2.1 or 2.2. You need to restate the sentence. So notice I have a picture of two lines. They're crossing. And so it says, if you have two intersecting lines, then, and then the second picture is, their intersection is exactly 1 point. So that's what we need to write. That's what the postulate states. I wonder if I should do this in white. So if two lines intersect, then their intersection is exactly 1 point. So when you're doing this on your homework or a test or a quiz, don't tell me that it's postulate, I think it was 2.3. You need to rewrite the sentence. Then the next one, notice I've got two planes in my picture, and then they're showing the red line there. They added that after the word then. So this is going to be the statement that if two planes intersect, then their intersection is a line. Now, if you want to name this first one and tell me that it's the line intersection postulate, you can do that. Or it's just easier to say what's happening. Let me rewrite that. So if you want to call this one, if you want to give it a name, call it the line intersection postulate. And then this next one, you could call this the plane intersection postulate.
Miss Corey?
Yes.
Taylor got kicked out of her Wi-Fi because of her Wi-Fi, but now she's in the...
Okay, let me let her in. Thank you. Okay, so then I'm going to restate the postulate, and it says if two planes intersect, then their intersection is a line. Example 2. Use the diagram to write examples of the plane point postulate and the plane line postulate. So let's go ahead and state what this plane point postulate is. So what we can say is for the plane point postulate, that states that plane P contains at least 3 non-collinear points.
Excuse me, Miss Corey.
Yes.
For us, it's a little bit different. It just says use the diagram to write examples of postulate 9 and 10.
Okay, so, so I need to modify that. Okay, so let's go ahead and instead of postulate 9, because that was in an old book, I want you to change postulate 9, change that word to plain point postulate. And what the plain point postulate states is that a plane contains at least 3 non-collinear points. So in this picture here, I'm talking about plane P, and those 3 in this plane could be points A, B, and C. And then on yours where it says postulate 9, replace that with plane line postulate. And we're going to say that the plane line postulate for this picture is we could say that point A and point B lie in plane P. So line N containing points A and B also lies in plane P. So that was the postulate that stated that if 2 points lie in a plane, then the line that contains them also lies in the plane. And specifically about this picture, we can see that A and B are on the same line, and that line N, which is what contains A and B, is also in plane P. Again, you're not going to get anything that's going to say postulate 2.1 or postulate 8 or 9 on a test or a quiz. Again, just know what it states. And in this case, we could name those postulates and call it plain line postulate or plain point. Next slide. It says, which of the following statements cannot be assumed from the diagram? So we're going to go through each one. So A, B, and F are collinear. So let's find those points. So A is here, B and F, they're all in the same line, so we can check that. We can assume that. E, B, and D, so E is over here, B is over here, and D, there is no line drawn through that, so we can't assume that. And then AB, notice the upside down T, that's the symbol for perpendicular. Let me erase some of these yellows. So AB, let's find AB here. AB is this line. And it says that it's perpendicular to plane S. And we can conclude that because it's got that little right angle mark in red. And then CD, let's go find that one. So CD is over here, and it says it is perpendicular to plane T. So let's see, can we assume that? No, we can't. There is no right angle. And then AF intersects BC at point B. So let's find AF. Let me erase some of this. So AF is here, and it says it intersects BC at point B, and we can assume that. So we can't assume this one because there is no line drawn connecting the points. So we can't assume that they're collinear, even though it looks like they are. And then the other one, there's no right angle mark for this one, so we cannot tell for sure if it's perpendicular. Everybody good on example 3? Last example. It says name a pair of supplementary angles and a pair of vertical angles in the diagram. So let's go through and find all our supplementaries. So supplementary angles. And I'm going to name them with 3 letters. Remember, supplementary angles are 2 angles when you add them, and they equal 180 degrees. So if I start with, let's say, PWT, this one over here, then I could put it with TWQ, and notice they form a straight line. So I could say PWT and TWQ. Now you could go in reverse order of the letters, but the W needs to be in the middle. So you could have also called this one TWP, and then you could go in backwards on this one and say QWT. Either one of these would be supplements. Then you could also go this way with the P, with this same beginning, the PWT. You can also say together with PWV. These are also supplements, and put the little angle symbol in front. Or you could also reverse the letter on these. So you could say TWP, and then you could call this one VWP. These are all supplements. Now we can go around. So you don't need to name all of these. When it says name a pair, any of these would be acceptable. Now we also have another pair. If we come over here, let's see, VWQ. So we can go this way, and we could say VWQ along with QWT. Those would be a pair of supplements. So you could keep going around and just find a pair, and that would form supplementary angles. Does that make sense? All right, let's do some vertical angles. So remember, vertical angles are not adjacent. So this, we could start with this one. Looks like a V. Let me do this one in white. So I'm going to call this PWV, and it's going to be vertical to this one over here. And I could say that it's TWQ. These are vertical that I'm writing in white. You could have also reversed the letters. You could have said instead of PWV, you could say VWP, and here I could reverse. And then I have another pair over here on the sides, these two. So another pair could be angle PWT along with angle VWQ, or go in reverse order, TWP, QWV. These are vertical. And we're going to be learning coming up that vertical angles are congruent. And we will use vertical angles a lot throughout the school year.